Hello, y'all. We are going to look at graphing trig functions today. So we just finished a unit. And if you think back to that unit, we looked at the unit circle. And I want you to go back with me for a second and think about these were ones and zeros, right? Whoops. One. Right? So that's cosine and sine. Right? So if we take these ones and zeros real quick and we write those down, sine of 0 was 0, sine of pi over 2 was 1, sine of pi was 0, sine of 3 pi over 2 is -1, and sine of 2 pi was, of course, back to 0 because 2 pi and 0 are the same. Okay, essentially what we did is we had a circle, right? And it went out to ones and zeros. What we're doing today is we're kind of snipping that circle, like if we had scissors right there, and we're going to unwind this circle, and instead of going around in a circle, we're going to stretch it out. The numbers won't change, so let's look at this. Okay, so at 0, sine was 0. And I'm going to put a 1 there and a -1 right there, right? So at 0 pi, sine was 0. So we're going to graph that. At pi over 2, sine was 1. At pi, sine was 0. At 3 pi over 2, sine was -1. And at 2 pi, we were back to 0. Okay, this never stops. It's a repeating pattern. So if you look at it, you can see that it goes middle, bottom, middle, top, middle. So I know this one's on the bottom, middle, top, and it's a wave. It's a sine wave. And what that is, it's like we have taken this circle, we have a circle, and it's like we snipped it and we unwound it, so we're going out. So this is like a repeating pattern over the unit circle. And that is a sine wave. We want to look at some of the characteristics of that sine wave. The domain. Domain means what? Left comma right. So this goes on forever. So it's going to be -infinity to infinity. Another way to say that is all real numbers. The range. Remember, range is bottom, top. So this bottom is at -1, the top is at 1, and it actually touches them. And the period. The period means how long does it take to start repeating the pattern. So if you notice, we go 0, 1, 0, -1. At 2 pi, we're going to start to repeat that pattern, and it's going to go 0, 1, 0, -1 again. So the period is 2 pi. Let's look at the x-intercepts. Okay, and every time we do this, we're going to write our notation 0 to 2 pi, and we're going to leave that open. That means we start with 0, we end at 2 pi, but we don't include the 2 pi because it's a parenthesis. So the x-intercepts, 0, 0. We have another one here, pi 0, right? And the y-intercept is 0, 0. Right? Does that make sense? If you need to, go back and look at this again and think about where these numbers came from and how we got them onto the wave, the sine wave. Okay, cosine is going to be exactly the same idea. We just have to figure out what numbers cosine has. So when we think about cosine, cosine is the x value, correct? So for cosine, we're looking at the x's. At 0, cosine is 1. Pi over 2, cosine is 0. Pi, cosine is -1. 3 pi over 2, it's 0. And of course, back to 2 pi is 1. Notice again, this is a pattern that's going to repeat forever. All right, so let's graph that, 0, 1. So again, I'm going to put my 1 and my -1. I'm going to scale that because I like to see it. So 0, 1, pi over 2 and 0, pi and negative 1, that's a little pi, 3 pi over 2 and 0, 2 pi and 1. And if you notice, top, middle, bottom, middle, top, so middle, bottom, middle, top. I'd really like for you to think about that as top, middle, bottom, or top, center, bottom, or high, center, low, whichever way makes sense, because it's a repeating pattern and it always does that. It never goes top, center, top. It always goes top, center, bottom. And this is a pattern that goes on forever. Okay, so the domain of cosine is going to be the same as it was for sine. It's a wave that never stops. If you think about it, you can see the sun. The light left the sun 8 minutes ago, and it gets here, and it's traveling in a wave. And please remember, these are curved. Do not make them pointy like that. They have a nice curve, as curvy as you can make them. I'm even going to erase that. I don't want you to think about it. But please don't make them real sharp and pointy. The range, it still has a bottom of 1 and a top of negative 1 and a top of 1, so that's still negative 1 to 1. And the period, notice we start at 0 and we start to repeat again at 2 pi, so that's a 2 pi period. Now the x-intercepts for this one are pi over 2, 0. Notice x-intercepts are always going to be wherever y is 0, so they're easy to pick off your chart, right? And 3 pi over 2, 0. You can look at them here, or you can look at them here where it crosses the axis. The y-intercept right here is 0, 1. Okay? If you need to, take a minute to look at that. This is extremely important because tomorrow we're going to start moving these around, so please take the time to memorize those. Okay? All right. Let's look. You know who's left. We got our tangent, guys, so let's write down tangent. Now, what's true at 0? What is tangent at 0? Tangent is 0 at 0. What is tangent at pi over 2? Undefined. At pi at 0, 3 pi over 2, it's undefined. Pi over 2, it's 0, or 2 pi, it's 0. Now notice we go 0, undefined, 0, undefined. So here we start to repeat our pattern. So the period for tangent is just pi. By the time you get to pi, you're starting that period over again. Okay, so I'm going to erase that so it's not on your thing, but I just wanted to show you. Okay, so we need to graph that. So 0, 0. Now pi over 2 is undefined. How do we graph undefined? Okay, undefined is graphed as an asymptote. So we're going to have an asymptote there at pi over 2. Then at pi we have 0. Then at 3 pi over 2 we have another asymptote. And at 2 pi we have a 0. Then of course you see the pattern. It's asymptote, dot, asymptote, dot, asymptote, dot, asymptote, dot. Okay, and I want you to think about this. Now you got to figure out, where do the branches go? Does it look like that? Does it look like that? How can I remember? Well, remember, 0 to pi over 2 is quadrant 1. Pi over 2 to pi is quadrant 2. Pi to 3 pi over 2 is quadrant 3. And 3 pi over 2 to 2 pi is quadrant 4. How does that help us? Well, let's look at tangent. Tangent is positive here and here, and it's negative here and here. So quadrant 1 is positive, quadrant 2 is negative, quadrant 3 is positive, quadrant 4 is negative. How does that help? Well, negative means you're below the x-axis. Positive means you're above the x-axis. So in quadrant 1, I'm above the x-axis, right? Quadrant 2, I'm below the x-axis, but then in quadrant 3, I'm above. So if you'll think about tangent this way, You will never get it mixed up with cotangent, which we're not looking at right now, but they look exactly alike except shifted over and backwards. So it's very easy to get them mixed up, but if you'll just think about your quadrants and this right here, you'll never be mixed up, right? And so what is the range of tangent? Well, the bottom goes on forever and the top goes on forever. So the range is all real numbers. Now, what about the domain? Do I have to sit here and write every single one of these down and say, okay, pi over 2, 3 pi over 2, and keep going forever? No. What we say is that the domain is all real numbers except where we have those, and if you'll notice, we have those on odd multiples of pi over 2, okay? It's 1 pi over 2, 3 pi over 2, so we could then go to 5 pi over 2, any odd number. We don't want to include even ones because if we said 2 pi over 2, 2 pi over 2 would really reduce to pi, and at pi, it is defined at 0, so that's why. The x-intercepts, what are our x-intercepts here? Well, we got one at 0, 0, right? We have another one at pi 0. Whoops, why did I do that? Right, and of course 2 pi, we're going to say from 0 to 2 pi, and we're not going to include the 2 pi because we don't want to keep writing forever and ever. And the y-intercept is 0, 0. And actually a lot of times in tangent, you will see them just go from 0 to pi because that's where they start writing over. So if you're looking at tangent, you may see the domain is really just 0 to pi. And if we changed it from 0 to 2 pi to 0 to pi, then we would just have, and we put a parenthesis there, then we would not include this one. So no matter how you see it in Delta Math or any of your other math platforms, you have to look and see what they're identifying as the domain. Please take a second if you need to and go back over those graphs. Very important that you commit those to memory. Okay, some other questions that you might see. I may be zoomed in too far, huh? Okay, so solve over the interval 0 to 2 pi. So when we look at your brain, right, when we look at this brain, most of the time I was asking you what sine of 5 pi over 6, and you were saying, oh, that's a half. So right now what I'm going to do is say, you know, the answer is a half, so what angle did that come from? And you'd be like, well, that came from pi over 6. Let's look at this. So given sine theta is -1/2. Now, first we're going to say where is sine negative? Sine is y, so it's negative in the bottom. 1/2 is a pi over 6 family, 30 degrees. So you need to name what's the angle here and what's the angle here. And you know we've been practicing, this is 6 pi over 6. This is 12 pi over 6. Okay, so if this is 6 over 6, then one more would be 7. And if this is 12, we go this way. So this quadrant is 1 before 12, which is 11. Okay, so we're just looking for those answers, and you already know all of these. Okay, let's do this one. Cosine is the square root of 2 over 2. Well, that's a 45-degree family, and it's positive, and I know cosine is positive on the right side. So I know way over here, this is going to be 8 pi over 4, right? Because it's a pi over 4 family. So this is going to be 7. This will be 1 pi over 4. And then over in this quadrant, it's right before the 8, so that's going to be 7. Okay? All right, tangent is -1. Well, tangent is -1 at the pi over 4 family. That's your memory work you've already done. And then tangent is negative here and here. Since this is 4 pi over 4, That's going to be 3 because we go in this direction, right? So before the 4 comes 3. Then all the way over here would be 8 pi over 4. So we're going to get this far, and that's going to be 7 pi over 4. Okay, does that make sense? Hopefully. This one says in degrees. So tangent is the square root of 3 over 3. That's a 30 degrees. Sorry. That's a 30-degree angle, 30-degree family. It's positive, and tangent is positive here and here. So, of course, the first quadrant is just what it is. So that's 30 degrees. And this one, that's 180. So 30 past 180 is going to be 210. Not so bad, right? But this is depending on the fact that you're remembering that brain that we wrote out. So again, very important that you have that in your mind. Okay, what about these equations? Notice here we're identifying f of x as sine, g of x is cosine, h of x is tangent, and j of x is secant. So all we're basically doing here is plugging them in. This says f of pi. That means plug pi into f. F is sine, so sine of pi equals 0. G is cosine, so we're saying pi over 2, so I'm going to say cosine pi over 2, and we know that cosine of pi over 2 is 0. C is 3 pi over 4 for h, so I'm going to plug that in and say tangent of 3 pi over 4. Now I know if it's got a 4 bottom, tangent is 1, but I need to see where that is. 3, this would be 4 over 4, so 3 would be here because we haven't made it to the 4 yet, and tangent is negative in that spot. Okay? What about this one? F of 2 pi plus j of pi over 3. That simply means, I'm going to do my colors, right? That means sine of 2 pi plus j is secant of pi over 3. Now sine of 2 pi is 0. I don't know secant, so I'm going to think cosine. We always think cosine and then we turn it over. Cosine, this is 60 degrees. Cosine of pi over 3 is 1/2. So to get secant, I have to flip that over, and 1/2 flipped over is 2, and 0 plus 2 is 2, right? This one is g of 120, so that's cosine of 120 minus sine of 210. 120 is 60 degrees away from the x-axis, so that's a 60 degree. Now 120 is in the second quadrant, so cosine is negative. Sine of 210, that's going to be over here. Sorry, it's 60 degrees. I meant to write down cosine of 60 is 1/2. So negative 1/2, and we have a minus sign. And then we've got sine of 210. 210 is 30 degrees away from 180, so that's a 30-degree angle. Sine of 30 is 1/2, but 210 is down here, so that makes it negative. And what do we get? We have negative 1/2 plus 1/2, so we have 0. Remember, when you're looking for angles, you always have to take into account where is this thing. Last but not least, j of 60. So what do we have? We have secant of 60 times tangent of negative 45 all over cosine negative 180. So we've got to think about all those. Secant of 60. I don't know secant. I know cosine. Cosine of 60 is 1/2. Therefore, secant is 2. So that's 2 times tangent of negative 45. That would be down here. Tangent of 45 is 1, but in this quadrant, Tangent is negative. And then cosine of negative 180, that's right there, and that's negative 1. So that equals negative 2 over negative 1, which equals 2. There you go. I think that's everything for today, and you've got some work to do. So I will see you next time. If you need to rewatch this or look at it again, please feel free. Adios, amigos.